All right, we're now going to move on to solving some problems we couldn't solve before, but because we have these complex numbers, we can now. So this here is a quadratic equation. I've used z's rather than x's. Really, that z's could have been an x, but the z implies it could be a complex number. And if I did my determinant here, I would find that my determinant was negative, and thus we would traditionally say there's no solutions. But in a complex world, we can say there are solutions, and again, it's still be two solutions. So we're just going to apply our normal quadratic formula. So minus b, so minus 5, plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So a little bit of just cleaning this up. So 4 times 3 is 12 times 3 is 36. 25 minus 36 is going to be negative 11. And 2 times 3 is going to be 6. So now all I'm going to do here is I'm going to separate them. So minus 5 plus. Now rather than the square root of negative 11, I'm going to say square root of 11 I, because this is 11 times square root of negative 1 all over 6. Or, and then I can just do the same, but this time with the minus. And so we can solve problems that we couldn't solve before because we have complex numbers. We can also factorize some things we wouldn't have been able to factorize before. So looking here, this looks very much like a difference of 2 squares, but this is a plus rather than a minus. Well, let's put a minus in there. And in order to compensate for the second minus, I'm going to put an I squared. Now I've got a difference between 2 squares. This is z squared, and this is 4i squared. So z plus 4i, z minus 4i. Now, something like this one's a little more tricky. There's a 2 there. Sorry, I wrote over the top of it. I'm going to do a completing the square. So my square is going to be z plus 1 because it's the half of that. So that's z squared plus 2z. Let's just put a little dash on it, just make it really clear that it's not 22. Plus 1. Now I've got to do a minus 1 to account for the plus 1 of there, and then the plus 5. So all of this bit becomes z plus 1 squared, and I get plus 4. And I'm going to just really quickly go, I'll actually make that a minus 4i squared. Do my difference between 2 squares. Z plus 1 plus 2i, z plus 1 minus 2i. Notice that these are the conjugatives, and they're always going to be that way. All right, that's that.